Hello everyone. If you are interested in learning about machine learning life cycle, this video is for you. Whether you solve a very small business problem using machine learning or you are solving a really large scale problem with machine learning, the machine learning life cycle is always going to be the same. Hello again, my name is Avkash. And in this tutorial, we are going to cover the 4 distinct stages of machine learning life cycle. These stages are data preparation as the first one, and the machine learning training and tuning is the second one. The third stage is related with machine learning model deployment and monitoring, and the last stage is related with inference or the model survey. We will look the functional component, means what happens in each stage at functional level and how these different stages are connected together, how the information transfer from one stage to another, and how all these 4 stages work together in synergy to solve a business problem in machine learning. So this tutorial mainly focuses on the machine learning lifecycle functional view. However, I do have another tutorial which is related with the deep and technical detail view of machine learning lifecycle. In that tutorial, I have went very deep and looked most of the small and large component at each stage and how they work together to solve a business problem. So if you are interested to go into the deep and learn more about machine learning lifecycle, I will suggest you to please click the link in this video and you can jump to that tutorial. The link is also available in the video information section, so you can also view that tutorial later. I'm super excited to make this video tutorial for you. So let's get started. This tutorial is motivated from this article from Amazon AWS. This article was focused mainly on Amazon AWS machine learning services and the architecture of a machine learning pipeline created using Amazon SageMaker. I like the image I like the whole detailed machine learning lifecycle view created by the author. So I have used the image to create the content for this article. So the full credit goes to the content creator who created this image, and that gave me motivation to create my own tutorial around it. So I appreciate their help. Now let's come back to our tutorial. If we go little more deeper into machine learning life cycle, this life cycle is divided into 4 main components. The first one is data preparation, and the output of data preparation component is the machine learning ready data. It means your data is machine learning ready and now it can be used for machine learning training. The second component is the machine learning training. In this stage, we build machine learning model using the machine learning ready data. We fine tune our model, and the output of this second component is your machine learning model. In the third stage, we deploy the machine learning model and monitor its usage. The machine learning model deployment can be done in varieties of ways. It's all depend on what kind of machine learning problem we are solving and how that machine learning model is going to be consumed by the problem itself. And the fourth stage is the inference, or the stage where we are actually performing the prediction or serving our model for our business need. So the inference level where new data comes and we use that machine learning model which is deployed to provide the prediction or the score which can be used subsequently depending on whatever the business need is. So these four components are very important part of machine learning life cycle, and now we are going to go a little more deeper and learn what happens in each stage. Our objective here is to look into the machine learning life cycle from functional point of view. It means what kind of functionality happens in each of these stages. At very first, we have data preparation. Data preparation is a collection of various steps. At the very first stage, we collect data which is coming out from various sources. These sources could have the stationary data or the saved data such as databases. Or the data could be the data which is in flight, or it's a stream data. The data could be any type, could be structured data or could be unstructured data. So the data collection step is the place where all these various sources of data collect, combine various types of data depending on machine learning problem, and now that data is ready for us to prepare it so it can be machine learning ready. In the prepare data phase, we clean data, means we try to remove the duplicates, impurities. If there is some missing information, we augment that thing, we prepare all kinds of things. And then after, we normalize the data. The normalization happens, means we try to study the data much more deeper and try to adjust the data depending on what is our business need. Another step we perform is the standardization of the data. We make sure that the columns, row, the data, if the data has labels, do we have proper information related with those labels are there? So anything related with data preparedness is completed at that stage. Sometimes we might need to add labels to the data depending on what kind of data is it. Mostly it could happen with unstructured data. However, if labeling is needed, in the data preparation stage, we do label the data. We encode the data, as I mentioned, depending on the standardization of the data. We look into that and we make sure that everything is standard as needed. Then, if in case we need to encode the data, we encode the data. There could be several other steps we need to do that come into the deep level of functional view, but at least at this point, we understood that data preparation is a collection of these steps, and these steps help us to create the machine learning ready data. Once data is machine learning ready, it means now it can be used for feature engineering. Feature engineering is a step where a data scientist or an automated process can extend the data in a way that the more new features are added to the existing data set. These features can be created based on mathematical approach. They could be created based on domain expertise approach. When we say the mathematical approach, it means that you can combine two or more features or available column to create a new feature. Or you can just decompose one particular column and you could create several features. So for example, a date column can be decomposed into several new columns. Days, year, which year it is, when the event happened. You can also use the date column and you can create a new column where you could say that the event happened from now. So the date will be subtracted from the current or now value, and then the days, a number of days or number of hours depending on how your time resolution is in your date value, you could create these hours from now or days from now columns. So various things can be done at feature engineering stage. And the feature engineering stage is just added in the data preparation phase so that you have a very meaningful data. Data has a lot more information, means it has a lots of signals which can be used for the machine learning model to learn more about data. The automated feature extraction is the similar stage, which is similar to feature engineering, where you could use these automated methods. And number one in that, and the number one technology for that could be the genetic algorithms, where you could use the biological algorithms to extract new features. So there is a lot more information available in public domain, so please look into. So the data preparation phase is basically the collection of the data and then making this data available in a way for the machine learning training so that it's feature rich, it's machine learning ready, and this is the best data available for the problem you are solving through machine learning. The next stage of machine learning life cycle is the machine learning training and tuning. In this stage, you take the machine learning feature-rich data and you fed into your machine learning training process. This training could be very complex, could be very simple. There could be several technological advances and functionality you could add. And once your training is completed, you validate the results from your training. So validation is done. And validation is basically there to make sure that the machine learning model which you are trying to build is really going to solve the problem you are trying to solve. Validation will prove whether your model is built correctly or not. First. Second, is it valid for a particular problem or not? So you have to do the validation at both stages. For the functional validation, everything is right. Second is a validation for the problem specific. Various experimentations will be needed in order to perform this training and validation. You could do automated way this training, could be done scripting, could be done through automated process, could be done on demand. While the training is being done, you can inject certain code to make sure that you have your machine learning training is done in a way that it's meet your business requirement. Once everything is there, it is very much possible that down the road you might need to fine-tune your model. As your model is being used to solve a particular business problem, you still keep checking and validating that is your machine learning model is performant or not. So the tuning part suggests us that if we believe or we experience that the machine learning model performance is decaying after usage or during the usage, you very quickly work on experiment your pipeline again so that you could fine-tune your machine learning model so it can be ready to solve your business problem. The next step in machine learning lifecycle functional design is the deploy and monitor. At this point, when you believe that your machine learning model is ready and can solve your business problem, you deploy it. And when you are trying to deploy your machine learning model, you are doing a test with the data which has not been seen by machine learning model, means a true test to bring the machine learning model in as close as possible real life problem. You could do A/B testing like any other functional testing we do in software engineering. And there could be various ways. And now these days, the technology, machine learning technology is advancing even more. It means that you could even do the testing at very detailed. Once your machine learning model tests are completed and you believe that machine learning model can be used to solve the real business problem, you could deploy it. Once the deployment is done, it means that you need to deploy this machine learning model, which is applicable to your business, where you could use this machine learning model depending on what your problem need or how your problem can use your machine learning model. These deployment methods could vary depending on how your machine learning model is going to be used. It means maybe if there is an automated way you want to use this machine learning model for every incoming data, you might want to do at a batch level. It means a lot of data is being sent to your machine learning model, and the result is also generated through a batch, or it could be done at a one individual record level as the information is coming, and you are immediately using machine learning model to predict your results so that you could collect those results and apply them to your business or whatever your project specific needs are. When you are deploying your machine learning model, sometimes inference or scoring could be a collection of several steps. And for example, we could say about a login to a banking system. So if you are using machine learning and you are applying machine learning technology while you are logging into a banking system, the machine learning models will check and validate that who this person is, their score, for whatever reasons you want to understand that, oh, is this a correct person or not? If this is a fraudulent person, what level of access this person should have, or this person should not have any access at all. So there could be several decision-making steps would be needed in order to successfully log a person into a banking system or a very highly protective system. Could be anything. So these collection of machine learning model are being applied so that within few seconds, or maybe just a few milliseconds to just a second, the decisions are made so that this person who is requesting the login access to this service, decision could be made. So several models can be used for that reason. So this is one example, but there could be thousands of examples where we could see that several models are being used to perform the decision making with regard to a one single event. So in deployment, there could be many models working individually, or you can deploy them many models. They are working as a one compounded model. It means one single entry point could generate several machine learning model inference system underneath, and then collectively the results of all of these individual inference can be pulled together and the final result could be made. And the result decision making could also be done based on how the weights of each model prediction is being accounted for. So there could be full rule engine, or rules can be created, or there could be a model which can collect all the results which is coming out from all of these models and can predict the final decision. So it could be anything in that regard. So once you have made sure that your model deployment, everything can be done, now there are a couple of ways you could deploy this model, and depending on your need, as I mentioned, that you could have the hosted endpoint, means a one single endpoint which could be used to subsequently perform the inference, and there could be one or many models are being used underneath to provide whatever feedback or whatever decision making is needed. For the batch processing, you are sending data directly, and there is a pipeline, or there is a whole inference system is designed for you so that new data is being sent to a runtime engine where new data is read and transformed as if needed so that it's ready for machine learning model to be applied and results can be created. So both functionality can be used depending on what your business needs are at the model deployment and monitoring status. When your machine learning model is used, you also need to monitor its usage. You are monitoring the usage for security reason, for unauthorized access reasons. You are also monitoring to make sure that your model is performing well enough. So all different kinds of monitoring can be applied depending on what your business needs are. Finally, inference means everything is ready. Now, whoever your users are, could be an IoT device, could be somebody is trying to use a computer, could be a SaaS solution, could be a mobile device, could be users. There could be anybody who is using the machine learning model deployment endpoint where they could send new data and get the results coming out from machine learning model. So inference system, and again, it's all depend on how and where your machine learning models are used, and they are trying to solve the business problem. And when you are performing the scoring or serving your model, as I mentioned, that there could be new data coming as row by row, and your machine learning model is just performing for every incoming request, and it could be distributed inference engine. It means you are processing hundreds, thousands, millions of new records coming as they appear in the system, and machine learning model is validating these new record. And very good example could be the financial transaction. So for example, if there is a banking system where you do have the anti-money laundering solutions are applied, so every financial transaction is coming in real time, and it's being validated at the real time by the inference server or inference farm, whatever you call it, and every individual financial transaction is validated for being it fraudulent or not in real time. So in order to process a system like that, you must need a really large distributed system where the inference can be done at thousands and tens of thousands to even million record per second level, or even lower resolution, a few millisecond level. So that's all has to be managed by the inference part. So sometimes, depending on where your machine learning model is applied, the inference itself is a very complex process, and it just required a very large amount of engineering to support the need of a particular business. So all these four components, they all are individual. Each level you are going to get some of the output, and those outputs will be fed into the next step. And once you combine all of these four components or four stages of machine learning life cycle, you have your full end-to-end machine learning pipeline ready. So finally, once you are monitoring and your inference is ready, and at that point, if your monitoring results suggest that your machine learning model is not performant enough, or maybe there is a lots of new data available, and even when everything looks okay, you want to train your machine learning model so it has knowledge and understanding of new machine learning data, you would want to retrain your model. Retraining your machine learning model is all done through experience, all done through your understanding of your data, and finally, depending on how your model is performing. So it's all depend on business to business or the problem to problem. Sometimes you need to retrain model daily, and sometimes you doesn't really need to retrain your model for even a year. So it's all depend on how frequently your data is changing, and as your data is changing, you really need to make sure that your model understand that changing in the new signals in your data, so that it can solve your actual business problem as your data is representing to it. Depending on business to business, vertical to vertical, problem to problem, organization to organization, and depending on how capable the team is who is solving your machine learning problem, this machine learning pipeline could be created differently. There are various solutions available these days which solve this machine learning problem. Starting from Google, Microsoft, Amazon, all these large companies, they have these cloud solutions available in market to solving enterprise level machine learning problem with variety of machine learning solution they provide. So depending on what product you are using, which cloud service you are using, companies like H2O, AI, Data Robot, Data IQ, Domino Data Lab. These companies, they give you machine learning platform. And if you are using AWS, Azure, Google, everybody has their own. Azure has Azure ML. AWS has a SageMaker Studio where you could do end-to-end machine learning. Google has itself their own machine learning platform for structured and unstructured data. So depending on what you would want to do, where your problems, what kind of problems you solve, in summary, the functional design or functional view of the machine learning lifecycle is going to be pretty much match with almost every machine learning problem. Just few function here, few function there, some additional function there, some function will not be there. So that's all I had for you to learn at high level machine learning lifecycle functional view. I hope you have enjoyed this content, and I will be seeing you in my next video tutorial. Thank you. That's all, my friends. If you have enjoyed our content, please like it, share it, subscribe it. And finally, please remember, be good and do good. Thank you.